Okay, we're in section 97 of the notes. Contents, as always, examples, as always, and exercises, as always. What are you going to be doing over here? You're going to be looking at my draft version, my name is Ron Bannon, of Webster Wells's Advanced Course in Algebra. All right? Now, I realize there's some students out there that don't have access to the document, so it's really not doing much except listening to my videos maybe. But the document will be published soon. All right? So the bottom line is, right now the document is just available to the prison mathematics project participants. But in the future, it will be made available. And if you're interested in receiving a copy of it, all I can say is reach out to me, and I'll let you know it's going to get published. My name, let's get rid of that. My name is Bannon. I did it again. Let me get my eraser out. That doesn't look right. My name is Bannon, and the email address, Bannon, B as in boy, the @ symbol, NNON.US. All right, not bad. Let's keep going. So what are we doing now? We're going to move forward. We're going to see what the deal about this one over here is, and it's, use of tables. Nope, I'm not going to use tables. Now, when I was in high school, I did have a digital calculator, but I got to be honest with you, some of my teachers were rather old. They were insistent on using tables. I think it's crazy. You don't see tables anymore. And even looking at these tables, they're even hard to read. So what I claim over here is I don't want to use a table. I just don't want to do it. However, you may want to look through this section over here just to see how bad people had it. All right? Now, when I do this over here, I want to claim, when I'm looking at these things over here, I'm going to say that looking at it, I would like to have a rough idea what the log is. All right? So someone says, why is that important for you? It's important you start looking at things as if they had some kind of order or value. So I'm going to point over here, you know, it's a log, so it's base 10. So I'm going to say, and this was important also in Wells's time, you had to figure out where that number was. But here's the deal. I'm looking at log 168. And by the way, all I want to do is I want to locate it between integers. So I'm wondering, it's got to be some power of 10. So if I look at this over here, I would say this is clearly greater than the log of 100. Now, someone said, why'd you choose 100? Because I know it's log. And what would it be less than log of 1,000? Now, this should be more intuitive for you now. This is 2, and this would be log of 168. What's log of 1,000? It's 3. So I know the log of 168. You know, if someone said, what is it? It's approximately 2 point something. I know that much. All right? Now, again, I don't want to struggle with it, but I got to be honest with you, it looks like it's going to be way closer to 2 than it is to 3. But I really can't get a better evaluation of that. So what I would recommend you do, not to use tables, but to use a computer. And you should get the number I'm getting, including when I use Sage. All right, let's look at log 83. I'll write this down for you. And I'm going to place it between 2 powers of 10. Let me write this over here. I'm going to say log 10 squared, because that'd be 100, right? We'll go over here, log 10 to the first power. So I'm going to say it's between 1 and 2. Now, if I looked at that, I would say the log of 83 appears to be closer to 2. So I'm going to say 1 point something, but close to 2. Now, again, someone's going to get better than that. Right? I guess if I use numerical techniques, but I got calculators. Make sure you can match the number, by the way. All right, let's look at this one over here. It's a little more difficult. 9, I figure it out now. So log 9, well, I'm going to say clearly it's below 10. 9's below 10, by the way. And then, you know, what power? I'll write this over here. Log 10 to the 0, which is 1. All right, this is 10 to the first power. So this would be 0, log 9, and 1. What do I know about log 9 base 10? It's going to be a number close to 1, but below it, it's a fraction. And again, my understanding, I think you really should use a computer to do that. All right? Learn to use a computer. Let's do this one over here. And again, I'm looking at it. It's not easy, but I'm looking at it. And I want to write down for you just a general approximation. Log. And some people do this in their head. And that's fine too. Well, I'm looking for powers of 10. And let me write this down for you. I can say it's between 10 and 100. So what do you get? It's between 1 and 2. Right, so what I know the log 32.76 is, it's 1 point something. Again, my understanding for most students, you really do, we're in a modern age, learn how to use a computer, all right? Even if it's a four-function calculator, learn how to do that. All right, let's put this one down over here, a little more complicated, but again, it could be done. I'm not saying it can't be done. So, I would look at it, and I'm wondering, what's that between? It's more difficult, though. There's no doubt about it. All right, so let's write this down. So log, I want to get an approximate for it, log, and this is going to be 0.021508. It's a crazy looking number. And what I want to do is kind of discuss, where it would be, right, in the land of logs. And the land of logs, powers of 10. So let me just write these down for you. So like 1/10 would be 0.1. 1/100th would be 0.001. I'm sorry, I made a mistake there. I know I always accuse myself of daydreaming, but I don't know if it's daydreaming. Just, maybe I'm just not thinking. All right? Now, I'm hoping you realize that, I'm looking at that, and I could keep going with this. I mean, I could go to 1/1000th. I'll erase these later, by the way. But I hope you're looking at the number that we're interested in, this thing over here. And I'm going to say right now, 0.01 is definitely less than 0.02. So I'm going to write that down for you. So it's going to be log, whoops, sorry about that. It's going to be log, and I'm going to put this guy down over here. What's that going to be? 10 to the minus 2. Now I want to do a number above the 0.02. And I'm going to say this number fits the description of being above it. And what's that going to be? Log 10 to the minus 1. Now again, if you can do this, that's fine. I don't mind. So what I got? I got this thing over here. Sorry about that. So what do I know? It's between minus 2 and minus 1. So it's like minus 1 point something. Learn to use a calculator. But you can place it. When I mean place it between integers. All right, this one, let me get my eraser up, by the way. Well, I'm looking at it. And what I got to do is got to rewrite it. By the way, this was substantially more difficult than Wells's times. But right now, it's not difficult for us. We have digital computers to do it. So what I want to do, it looks really strange to me. I'm going to write this in exponential form. I can write it as 10 to the 0.6571. And I'm going to try to locate it approximately. All right? So I'm going to say, looking at power-wise, it's somewhere between 10 to the first power and 10 to the 0. Why is that? I'm looking at the exponent of 0.6571. That's between 0 and 1. So it's going to be between 1, and it's good to have numerical sense, and between 10. All right? So whatever the x is, that's what's going to be. Now, again, my understanding, you should use a calculator. On a calculator, it's going to look like 10 raised to 0.6571. And if you're doing a calculator, you're sure you get a number between 1 and 10, by the way, and that's the number that you should be getting. Now, granted, the precision might be different than mine, but you should get a number like that. Let's do this one over here, the number 7 now. And what do I get? I get 10 to the 1.3943. I'm going to say that's somewhere between 10 squared and 10 to the first power. What does that mean? This number is between 10. And again, we're just getting a numerical sense over here in 100. My understanding, if I were doing that over there, I would use a calculator. On a calculator, it would look like 10 raised to the power 1.3943. And a calculator can do that. And you can get a number between 10 and 100. It turns out to be that number that we're listing there for you. All right, let's put this one down. A little more difficult because a negative number. You might say, is this possible? Well, let's write it down. You're going to get 10 to the minus 1.4 735. Let's write this over here. So 10 to a power, 10 to a power. And I got to think about it. And so why do you need to think about it? I just need to think about it. So I'm going to say 10 to the minus 2 and 10 to the minus 1. I hope you realize that minus 1.4735 is between minus 2 and minus 1. So I'm going to say it's somewhere between 1/100th and 1/10. All right, what does that mean? 0.01. And again, I'm locating it. And this number here. So I know it's between those two numbers. What am I recommending you do? Your calculator. So what do you get? 10 caret minus 1.4735. If you use a calculator, you can get this number over here. And that's certainly between those numbers that we said it would be between. It's like 0.0. It's about 0.03, all right, between those two numbers. All right, let's keep going. Oh, no more to do. That's good news. Exercise. Exercise, my recommendation, use the calculator. I really mean it. Learn to use the calculator and learn to do it quickly. You were at an advantage over Wells. It would almost look like witchcraft if you showed Wells what a calculator can do. It's a substantial achievement. And he would have been impressed by it. There's no doubt about it. Anyone would be impressed by it. The digital calculator really has transformed mathematics. It really has. It's transformed it. It's made it, certainly more manageable. I always say during World War II, they knew how to write these massive problems down, but they did not have a computer to compute it. It just wasn't available to them. They couldn't have computed the things they wanted to compute. It just took too many man hours or woman hours or people hours when you look at it. But now we can really do massive amounts of computation in very short periods of time. Our digital computers have become incredibly, incredibly strong. All right? Again, mastering those. 24 questions. That calculator should be very easy. Sage, what is it? Computer algebra system or a CAS. It's free or open source. Download it. Use the interactive web application. Type in some code here if you want. But what am I really looking for? Hearing back from someone telling me they found an error. What's my email address? Bannon, B as in boy, the @ symbol, NNON.US. All right? So I'm going to say that's done, and we'll keep moving forward. Again, move forward at your own pace. You know what you have to do, by the way. You got to work hard in this stuff over here. Thank you.